Okay, students, let's talk about solutions. A solution is a homogeneous mixture that consists of a solute and a solvent. Typically, the solute is the minor component of the solution, and the solvent is the major component of the solution. Now, a solution is equal to the solute plus the solvent, okay? So when I make a solution, I take some amount of solute and I dissolve it in some amount of solvent, and that gives me the solution at some concentration. All right, so the solution is the solute plus the solvent. Okay, so if I was making, say, a 500 gram solution that was, say, 10%, that would be 50 grams of the solute plus 450 grams of the solvent to give me a 500 gram solution. Okay, so expressing solution concentrations in Chem 1, primarily what we do is we express solution concentrations in terms of percent mass solution. So for example, percent mass solution would be the grams of solute divided by the grams of the solution. So that's the grams of solute plus the grams of solvent. Okay, that equals to the grams of solution times 100%. So if I was calculating the percent mass solution of, say, the 50 grams of solute that I put in the 450 grams of water, then that would be 50 grams of solute divided by 500 grams. That's the grams of my solution times 100, and that would give me a 10% mass solution. Okay? Now, the other way we have of expressing solutions is molarity. Molarity is going to equal to the moles of solute divided by the liters of solution. Moles of solute divided by liters of solution, or millimoles of solute divided by milliliters of solution. So if you're going to be calculating moles or using moles to determine molarity, you need to make sure that your volume is in liters, that the volume of your solution is in liters. So if you're in milliliters, you need to convert to liters. So if I'm in milliliters and I want to convert to liters, then I just simply move the decimal place 3 places to the left, and that gets me in liters. Okay, so the units have to complement one another. Okay, when you're calculating molarity, if you choose to work in milliliters, then you have to convert your moles to millimoles. So that would entail moving the decimal place 3 places to the right to get in millimoles. All right. So if you're going to work in moles, make sure your solution, the volume of your solution is in liters. If you're going to work in millimoles, or if you choose to use milliliters, you have to make sure that you are using millimoles. Okay, so the units have to complement one another. I can't stress that enough, guys. All right. Okay, students, we've been talking about solution stoichiometry, and recall that molarity is one way in which we can express concentration of a solution. So the molarity is equal to the number of moles of solute divided by the number of liters of solution. Okay, So in this problem, they want us to calculate the molarity of a 2.50 liter solution. So the volume of our solution is 2.50 liters. That contains 61.0 grams of sodium chloride. So what we need is the moles of sodium chloride. And we can divide, once we have the moles of sodium chloride, then we can divide that by the volume of the solution, and that will give us the molarity. So we need to convert 61.0 grams of sodium chloride to moles of sodium chloride. Well, let's calculate the molar mass of sodium chloride. So we have one sodium, and so 1 times 23 AMUs, and then we have 1 chlorine, or chloride in this case, so that's 1 times 35.5 AMUs. And so we sum that up, that gives us 58.5 AMUs. Okay, so this corresponds to 58.5 grams per 1 mole, or 58 grams per mole, which is the molar mass of sodium chloride. So what we can do is we can say, okay, 61.0 grams of sodium chloride, and essentially what we're going to do is divide that by the molar mass of sodium chloride, which is 58.5 grams. So that grams cancel, that leaves me with moles. That's what I'm looking for, of course. And so what I end up getting is 1.04 moles of sodium chloride. All right. So remember, when I divide by molar mass, it's just expressed as 1 mole divided by the grams of that molar mass. Okay, so that's why I flipped it like I did. All right. So the molarity, now that we have the moles, we have our volume of solution, which is 2.50 liters. So now we can say 1.04 moles of sodium chloride divided by 2.50 liters. And when we carry out that calculation, that gives us 0.416 molarity. So that's the concentration of our sodium chloride solution, 0.416 molar concentration of sodium chloride. All right. We reported this answer to 3 sig figs because we have 1, 2, 3 sig figs here, and we have 1, 2, 3 sig figs here. All right. So that is how we calculate the molarity when we're given the volume of solution as well as the grams of solute. Must convert the grams to moles by dividing the grams of solute by its molar mass, and then taking the moles of solute and dividing by the volume of the solution expressed in liters. Okay, it has to be expressed in liters. Okay, in this problem we're asked how many grams of sodium nitrate is required to make 500.0 mil of a 1.25 molar concentration of sodium nitrate solution. All right. So in order for us to get at the grams of sodium nitrate, we need to find the number of moles of sodium nitrate. Okay, well, how am I going to do that? Well, we're given the volume of the solution, right? I can multiply that times the molarity of the solution, and that would give me the number of moles of solute. Okay? So remember that molarity is equal to the number of moles of solute divided by the number of liters of solution, right? So if I rearrange this, I'll put number of moles here. If I rearrange this, the number of moles, this gives me, if I'm looking for the number of moles of solute, then it's rearranged like so. It's the volume of the solution in liters times the molarity. So we need to convert the 500.0 milliliters to liters, so that's just going to be 0.500 liters. This 0 is significant, so 4 sig figs here. So when I do my conversion, I'll convert it to 4 sig figs. The leading 0 here is not significant. Okay, so now that I'm in liters, I can say, okay, the number of moles of sodium nitrate is simply going to equal to 0.5000 liters times the molarity, which is 1.25 moles divided by 1 liter. So liters cancel. That leaves me with moles, and so when I carry that calculation out, I get 0.625 moles. So this is the number of moles of sodium nitrate that I have in this 1.25 molar solution at a volume of 500.0 milliliters. All right. So now that I have moles of sodium nitrate, if I'm in moles of a substance, I can get in grams of that substance by multiplying the moles of that substance times its molar mass. So we need to calculate the molar mass of sodium nitrate. Well, it turns out that this molar mass, let's see, 23 AMUs, that's for sodium. I got 1 sodium. And I have 1 nitrogen, so that's 14 AMUs. And then I have 3 oxygens, so 3 times 16 gives me 48 AMUs. And so the molar mass, right, this would be 85 AMU, so the molar mass would correspond to 85 grams per mole or per 1 mole. Okay, so now I'm going to say the number of grams of sodium nitrate is equal to 0.625 moles, and we're going to multiply that times the molar mass of sodium nitrate. So that's 85 grams per 1 mole. So the moles here cancel and leave me with grams, and I get 53.1 grams. I could go 2 sig figs here. Since I have 2 sig figs here, we'll go 53 grams of sodium nitrate. So that's the number of grams of sodium nitrate I have in a 1.25 molar solution of sodium nitrate at a volume of 500.0 milliliters. Okay, so in this problem, it says what volume of a 0.250 molar concentration of sodium hydroxide solution contains 12.5 grams of sodium hydroxide. Okay, so let's see here. Let's look at our molarity equation, where the molarity we say is equal to the number of moles of solute divided by the liters of solution. Okay, so if we are looking for the volume of a solution and they give us the molarity in the grams, well, we need to think about converting the grams of sodium hydroxide to moles of sodium hydroxide, because after all, that's the amount of our solute. So if we were to convert the 12.5 grams of sodium hydroxide to the number of moles of sodium hydroxide, we could utilize our molarity equation. We could rearrange that equation where the number of liters of solution is simply equal to the number of moles of solute divided by the molarity. Okay, so let's convert the 12.5 grams of sodium hydroxide to moles. So the number of moles of sodium hydroxide is going to equal to 12.5 grams of sodium hydroxide, right, times 1 mole of sodium hydroxide. Let's calculate our molar mass here. So we have 1 sodium, which is 23 AMUs. We have 1 oxygen, which is 16 AMUs. And we have 1 hydrogen, which is 1 AMU. Okay, so that gives us 40 AMUs, which that corresponds to 40 grams per mole, or per 1 mole. And so when we go from grams of a substance to moles of a substance, we divide the grams of the substance by its molar mass, so that it's expressed as 1 mole per number of grams for that molar mass of that substance. So that grams cancel with grams and I'm left with moles. So that I get here for the moles 0.313 moles of sodium hydroxide. So for 12.5 grams of sodium hydroxide, that's going to equal to 0.313 moles of sodium hydroxide. Now that I have moles of sodium hydroxide, I can calculate the number of liters of solution that I have. So I'd say 0.313 moles of sodium hydroxide. That's my solute. And I'm going to divide that by the molarity, which is, I'm going to expand this a little bit. This is going to be 0.250 moles. Remember, molarity is moles of solute per liter of solution. So I'm going to write 1 liter up here in the top because I'm dividing by the molarity. So the liter will flip up into the numerator so that I get moles to cancel. After all, that's what I'm looking for, right? Number of liters of solution. So This should be in the numerator, 1 liter of solution, okay? And so when I calculate that, I get 1.25 liters of solution, all right? Well, if the problem asks, it didn't ask here, but if the problem asks, what is this in milliliters? So the number of milliliters is simply going to, number of milliliters of solution is simply going to be 1.25 liters, and we're going to multiply that times 1,000 milliliters. We know that there is 1,000 milliliters in 1 liter, and so this would be 1,250 milliliters. Or if you wanted to get rid of that trailing zero, which is not significant, you could just say 1.25 times 10 to the third milliliters. Okay.